So next application of Gauss's theorem is electric field intensity due to a uniformly charged thin spherical shell. Here you have to just consider a spherical shell. The radius of the spherical shell which is taken as r and it is charged uniformly. So this is the direction of electric field. You have to take a point P at a distance r from the center of the spherical shell. Here we are going to discuss three different cases. The first case is field outside the shell. First case, field outside the shell. So here we have to consider the point P outside the shell at a distance r from the center of the spherical shell. To study Gauss's theorem, we have to just imagine a Gaussian surface. This is a spherical Gaussian surface. The radius of the spherical Gaussian surface is r. And next, you can just consider the smallest portion, that is delta S. So first, electric flux through the Gaussian surface phi is equal to E into sigma delta S. It is a spherical surface, so we know that sigma delta S which is equal to 4 pi r square. Then by Gauss's theorem, we know the equation phi is equal to q by epsilon 0. From both equation, that is from equation 1 and 2, we can write E into 4 pi r square which is equal to q by epsilon 0. Therefore, electric field intensity outside the spherical shell which is equal to q by 4 pi epsilon 0 into r square. This is the first case. And the second case, you can just consider field inside the shell. Here the value small r which is always less than the value r, capital R, that is the radius of the spherical shell. So here you can just consider this is the spherical shell. The radius of the spherical shell is r and the Gaussian surface is inside the spherical shell of distance r from the center of the spherical shell. So O to P, the distance is r. So in this case, the electric field intensity which is always 0. The reason is the Gaussian surface does not enclose any charge. The charge always resides outside, so that electric field intensity inside the shell is 0. And the next one, you can just calculate field on the surface of the spherical shell. So on the surface of the spherical shell, we can write r and r. The radius of the spherical shell and the distance both are always equal. If on the surface of the shell, the charge distribution is same as surface charge distribution. Therefore, here we can write electric field E is equal to sigma into delta S by 4 pi epsilon 0 r square. Then you can substitute the value delta S. So you get sigma into 4 pi r square, the whole divided by 4 pi epsilon 0 into r square. 4 pi r square cancel. So electric field intensity E is equal to sigma by epsilon 0. So the first case, field outside the shell, here you know that the value of r is greater than the radius of the spherical shell. There the electric field intensity E is equal to Q by 4 pi epsilon 0 r square. But inside the shell, the electric field intensity is 0. Field on the surface of the shell, the electric field intensity E is equal to sigma by epsilon 0. First two cases very important. To describe the field outside the shell and field inside the shell, it is compulsory you have to draw both the diagrams. The first you can imagine the Gaussian surface outside the spherical shell. The second case you have to imagine the Gaussian surface inside the spherical shell.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.